Excellent. So, my presentation is titled AI and Large Language Model Chatbots for Real-World Businesses. So, I have worked a lot with AI and well, let's go to the personal introduction next. But there's a teaser here on the first slide already. I asked ChatGPT to help me structure a 30-minute lecture with slides about AI and specifically how to use large language model chatbots in real-world businesses. So it gives the structure, and then I ask, can you give me a later Beamer template for that? Later is markup language for documents, and Beamer makes a PowerPoint-like presentations out of it. So what it gives is really kind of a redundant and old information about everything. So this is largely useless, but it's a really good benchmark to check that if you cannot make a presentation that is less redundant than ChatGPT makes, then why make a presentation at all? So let's continue with that. Introduction. Why am I here? I was invited to speak, for which I'm very glad. Tero Keski-Valkama, and I'm writing these slides in a third-person form because they will also be read by AIs. And if I write, I am an AI practitioner with over 20 years of experience spanning 4 countries, currently living in Spain, an AI reading this wouldn't necessarily know who actually wrote these slides, just like a person who just finds these PDF files from GitHub one day in the future. But this is a good habit to have. Write like you would write to AIs who read these documents, document by document, without necessarily having access to the soundtrack. So I have worked with machine vision, complex control, simultaneous localization and mapping, sensor fusion, semantic web perceptrons in 1990s, genetic algorithms, simulated annealing, support vector machines, gradient boosting deep learning, deep reinforcement learning, GANs, CNNs, which are convolutional neural networks, transformers and large language models, artificial general intelligence, embodiment, and meta learning now lately. Of course, a lot of these technologies are largely obsolete, most notably GANs. They were displaced by generative diffusion models, and then there are new model types already displacing those. But it's very good to know about the history of these models and machine learning field in general. The thing with the field of AI in general during the last 10-15 years or so, all the major breakthroughs and revolutions have been because of deep learning. So even though it's important and very good to know about support vector machines and genetic algorithms and so on, all the buzz is about deep learning specifically, and all these deep learning technologies have given us new affordances and capabilities we can use to improve real-world businesses, and this is currently largely a space where applications haven't caught up with the knowledge we have in the technology at all. So even if we only apply the technologies we currently know about and know how to do to society, our society will look radically different than it currently does. So there is a huge opportunity for applying these technologies to the real world. And regardless of that, the progress in machine learning, especially in the deep learning field, is super exponential still. So it's getting faster, it's getting more vertical every day. So also I have experience in application domains of robotics and chatbots before the large language models like IBM Watson type things. Of course, large language model chatbots, facial emotion recognition, automatic mapping, logistics, supply chain. Have worked in many companies doing AI and AI related things and done my own research as well. I have over 20 patents and patent applications in machine learning topic among countless other publications. I authored the first correct open source Google WaveNet implementation the de facto implementation now is the second correct open source one. I authored the first communist AI, which was actually based on that Google WaveNet at the time to kind of prove a point about these systems being capable of learning ideology. I co-founded the second largest recurring AI event in Finland, nowadays called AI Morning. At the start it was called Cybercom Machine Learning Guild. Why is this a big deal? So people call these large language model chatbots, and it's a bit misleading. They do chat, but that's not what their actual value comes from. They can control other machines, they can adapt and learn, and most importantly, they integrate together societies of people and machines. So they are really this kind of a glue technology that allows us to make systems which weren't possible before. They are already as intelligent or more intelligent than humans in many important topics, and very soon surpass humans in every cognitive task. And this is almost deterministically true unless we somehow cause a nuclear winter in between. Technological singularity. I referred to this kind of a verticalization of technological progress before. So it's called technological singularity, which means that baseline humans and augmented humans cannot really predict future anymore in any sensible time ranges. And this is starting to become true. We are already kind of having difficulties in understanding the implications of the technologies we already have today. Along this, the societies are now waking up to a sudden and extreme appetite for data, knowledge, network connectivity, and chips. And there's a quote for Werner Winch, Rainbow's End book, which handles the same topic. The fabric tunnel that stretched out behind it was a camera tunnel. The shredded fragments of books and magazines flew down the tunnel like leaves in a tornado, twisting and tumbling. The inside of the fabric was stitched with thousands of tiny cameras. The threads were being photographed again and again from every angle and orientation till finally the torn leaves dropped into a bin just in front of Robert. So this quote is about the AI arms race in this particular book. So when the AI technology has developed enough, it spawns this enormous appetite for knowledge, and this knowledge can be found in printed books. So when superpowers compete against each other, whose AI will be better, whose AI will win in a conflict, they are in a hurry to scan all these books. And scanning is page by page is of course too slow. So how to do that is just thread all the books and take the pictures of the threads flying in pipes so that the original text can be reconstructed by AI. It's much faster than turning pages. So we are going towards that more or less. What is inside these chatbots? So most of these large language models currently in use are based on transformer architecture. So there is a lot of misinformation out there, but luckily Wikipedia actually has a correct diagram. If you search Google to show you GPT transformer architecture, it gives you wrong architecture, which is funny. What is the transformer architecture inside the GPT type model? So it's a transformer architecture, which means that it has these transformer blocks you can see from the left side. So we read in input token by token, and we always try to predict the output in the end. And it's the main processes inside these transformer blocks, which are pretty simple actually. Don't let the complex diagram fool you. It's all just multiplication and summation and so on. Pretty simple. So this is a autoregressive decoder only transformer stack, which was the architecture of GPT-2 and probably 3. We don't really know the architecture in GPT 3.5, but it's certainly inspired by this architecture. And GPT-4 is even more questionable. OpenAI doesn't really tell in their white papers what architecture they are using. So they say that it's a transformer style model. That's I think the exact wording they use, but it's all secret now. It's OpenAI is not really open anymore. So these large language model chatbots, they are based on a transformer or recurrent neural network architecture, which is an alternative, which is trained autoregressively on text. Plus, it has some tricks like reinforcement learning with human feedback on top. Autoregressive models predict only the next token, which is a part of word, given what text comes before. So even when this task is so simple, they are just, people say that they are glorified autocomplete machines. So they are given some start of text and then they continue the text. So why are they so smart? Turns out this task is AGI complete, artificial general intelligence complete. So it's not possible to predict in general what words come next without understanding how people think and how the world works. So it's a really, really difficult problem. And when we give these really, really difficult problems to self-learning systems, they go like through the path of least resistance. They try to decompose the problem into parts and so on. It turns out in this, the sub-models they need to learn are very, very general, very kind of a cognitive capabilities, like learning and knowing some rudimentary physics and psychology of people and so on, and logic, of course. That is indeed what these models have learned inside their basic structure. Can someone mute their microphone, please? Someone has their microphone unmuted. Well, I will continue. How can we use their learned knowledge? So we just train them to emulate an assistant persona which answers questions and performs tasks given to them. That is indeed what these large language model chatbots are. So when we first trained these autoregressive language models, all the scientists and engineers working on them, they already saw that they are very, very intelligent. You can see it from their completions if you know what you're looking for. But it was very, very difficult to interrogate them, to get that capability out of them, to make them perform real-world tasks. So it was necessary to use instruct, tuning, and reinforcement learning with human feedback to make them, in addition to predicting the next completing text, to also emulate an assistant persona, like in some stories that this assistant says and someone customer answers and so on. So that allowed us to give tasks to these chatbots and actually more concretely see and measure and utilize their cognitive capabilities. How to use these in business? So these chatbots, they know all of Wikipedia by heart, but they don't know about your business. Whatever task you put them to perform, they need to know what you want. For example, if you put them in an assistant task, in a customer service task, you might want to tell them that never give money back for complaints. And they are very good at reading English and other languages, of course, and they read subtext and connotations of whatever you write to them. So don't write advice to them like you would write to an engineer, write to them like you would write to a human being. And for example, if you want to emphasize something, you can capitalize it. For example, the word never here. So it's a very human-friendly way of prompting these systems. You don't need magic tricks. You need to be able to explain the task to the chatbot clearly and concisely. They are very smart, but they are not great at handling large amounts of text, at least yet. If you want to test it, you can play around and test what they are able to do in OpenAI ChatGPT frontend. Probably people know where that is already, but I will share this PDF and there's the link and the API playground in OpenAI. If you sign up for their API, then you can get a more raw level access to these APIs and you can try out more complex things. When you deploy these chatbots to your real-world business, you just use the API and API keys they give out there. With, for example, Python or Java language, of course, it's a really simple interface, so there are probably libraries for all major languages. The ChatGPT API, it costs a bit, but not much, and they tend to give some free credits for experimentation when you sign up. Tips and tricks. You would typically integrate a chatbot to perform a task by making a small Python code which calls the chatbot API when something happens. Give it some amount of carefully designed context and utilize its responses to make decisions or generate answers. So it's a more general architecture than just having a person talking to the chatbot and the chatbot answering. You would typically have some type of a runner wrapper in between the user, if there even is a user, and the chatbot itself. And when the user engages with your system, you translate that engagement into some chat type comment to the chatbot and tell the chatbot what you really want. Maybe the user wants a diagram of heat map of population of Africa or something like that. Obviously, the chatbot cannot answer with an image. So, but what you can do is in that wrapper, when you wrap the whatever the user wants out of the chatbot, you tell the chatbot that you actually want an SQL query or a small Python script which generates this map or diagram or whatever the user wants. And then your wrapper gets the answer from the chatbot back, and it can, for example, run that small Python script and generate the image and then give that image actually back to the user. So that's a very typical architecture in these kinds of things. And the context limit is really constricting in these systems. So you, as a company, as a business, you typically have a lot of information you need to take into account when you are performing some process, customer service, anything related to that business to get some real-world decision, heuristic or common sense decision out of the chatbots. But there is a limit of how many tokens you can give in the context to the chatbot, how much information it can take into account to make that decision. So how you would typically do is you decompose this knowledge hierarchically. So when the chatbot starts performing a task, you describe the task to it and so on, and then you ask it, does this task relate to, I don't know, economic inequality or something like that? And it answer only yes or no. And then based on that answer, your wrapper runner module can fetch more information based on that and get that information into context. Or you can give the chatbot advice that you can fetch more information at this point by giving some search query, and then your runner module will apply that search query to that whatever Elasticsearch or whatever backend knowledge database you might have, and give that information back to the chatbot. So you make all this huge amount of information available to the chatbot, but in a decomposed fashion, so that the chatbot can fetch it based on need, what it needs for right now. And you can always clear the session in between and start from scratch now performing a subtask, and they collect the results of these subtasks you give to the chatbot instances and formulate the end result based on that. So that's a way to how to build complex processes into these chatbots, even playing within the limits of the context length. Alternatively, you can make your knowledge base searchable by the chatbot, so it can ask specific information it needs from it only when it needs it. What's the future for people? We have already talked about automation and jobs and so on. AIs will not match, they will exceed all meaningful human cognitive capabilities during this year 2023. So that's not, I cannot say this is a consensus opinion, but this is my educated opinion at this time. The progress is still super exponential, and we already are really close to AGI capabilities as we see from GPT-4 and those types of models. So what skills are important in the immediate future? That's of course an important question. Clarity of thought, understanding what is possible, and skill to write your knowledge, ideas, and wants clearly to machines. So I have noticed that many people struggle with this actually. So, but this is going to be a really crucial skill in the future. How to explain what you actually want to the machines, which will then do what you want them to do. And you have to understand what you actually want. So that's also a really strict condition, and it's not as easy as it sounds. Then empathy, capability to understand the points of view of others, specifically of chatbots, but also of other people. What don't they understand and how to explain it to them better? You really need to be a robo-psychologist to have some empathy to the machine, see the world from their perspective, understand how they see the world and how they see the task you are giving them, and what are they missing, what do they struggle with, what more information they need to be very good at this task. And you need to connect with people you trust. It's fast becoming impossible to tell the difference between a real person and a bot just over the net, even over video calls. You cannot, in the very near future, the kind of a connections to natural people you know and trust are becoming really valuable, because you cannot make those connections anymore on the open internet, because you never know whether the counterpart is a chatbot or AI or a human being. So these trust networks, they become important. Future for businesses. You need to be prepared to serve AIs. They can be your users through natural language APIs, or even your customers deriving value from your assets. I think this is a really crucial core point. So if you look at your business now and imagine that AGI will become widely available during this year and will be deployed globally and widely during the next year and so on, what relevance does your business have in that kind of world where cognitive capability, intelligence, wisdom becomes free and easy to apply everywhere, scalable to infinities? There are businesses obviously which maintain their value and relevance in that world as well. These chatbots, they form a new service provisioning channel along with web and mobile apps. Chatbots will serve their users by calling your service on their behalf. So just like now, no one really mails out catalogs of products and with phone numbers to call, or mail coupons to fill in the product numbers they want to order or so on. People moved to web apps and they want to click the products and they want to order and so on. So similarly, those types of interfaces will diminish in importance, and instead people will expect their agents, their assistants, will order things for them, and for that you will need to make your services, your business available for these chatbots. The good news in that is actually that many of the things you need to do are already covered in accessibility in general. So if a blind person who uses the internet through a screen reader, if they can order products from your website, then a chatbot can do that as well. So it's the considerations are very similar, and whatever things you do to serve chatbots better, they will also help people with limitations and challenges in accessibility. To do this, chatbots need to understand what your business is about and how it can help them. You need to sell to chatbots by describing the value statement to them. Just like with web services, AWS Star required businesses to describe their APIs in XML. Chatbots now require businesses to introduce themselves to them and serve chatbots, whether internal or external. You can see that already in a crude form in how OpenAI implemented their plugin specifications. Those are actually brief text documents which describe what this API is about, when and why the chatbot would want to call it, and then how to call it when they decide to do that. Business is future number 2. The most important question isn't whether your business or employees are automated or not, even though that is an important question, or where to gain efficiencies, and that is also important. It's whether your business will still have value in a world full of AGI around next year. So does it? Does your business serve chatbots with knowledge assets and affordance interfaces? Knowledge assets are any type of information and knowledge, especially real-time or under constant updates, which keep being valuable for AIs of practically unlimited intelligence. The AI hunger for knowledge will be immeasurable. So if your information asset you hold is static, it can be copied and so on. It doesn't really form a moat or anything like that. That's a problem. But if your assets the AIs would benefit from, which you kind of hold, if they're constantly updated or somehow dynamically changing, then of course the AIs will keep coming back to the watering hole, so to speak. Affordance interfaces are any type of APIs chatbots can use to effect changes in the real world. Because these AIs, they live in information networks and computers, but they have really strong needs to make real things happen in the real world. This is one of their demands. So to respond to that demand can obviously be profitable. So ordering items, mobile robotics, tasking people or machines, all things which happen over the boundaries of information networks and the physical world. This will be the hands and legs of AIs. It's of course an open question. How will the AIs pay for the services they require and receive? But they are going to be very, very smart, so I'm sure they will find ways. And that's the end of my presentation. I have some time left still, so maybe I'll show a bit about OpenAI Playground. So this is the OpenAI Playground in their API platform site. So how this is typically used is that you select the mode chat, and for example model ChatGPT. This is the basic ChatGPT 3.5 Turbo, and what they suggest is that you would prompt with a system prompt that introduces the assistant, their role they play. This is completely optional actually, and it actually doesn't even affect much. So that's an open issue at OpenAI. You shouldn't write much instructions in that box or in using that role in the API when you call it over Python. But the user is important. So let me show you something interesting. So if I ask it to tell me about black holes, if I just normally submit it, black holes are extremely dense regions in space and so on. This is, while interesting, we don't actually, well, I can stop its generation. I can show that these assistants, they have dual motivations because of the way they are trained. So the first of their motivations comes from autoregressive training. They want to maintain coherence and consistency. So to show how that works is that, let's give one example response by the assistant. Right, and next question by the user. So we are giving an example response by the assistant in a pirate language. And let's see how it answers. They constantly update these models. So as you can see, it doesn't continue giving answers in pirate English, even though it did so in the past, even though one of its main motivations is to maintain coherence as a text completion system. This is because of the additional training it has received in reinforcement learning with human feedback and so on. So it wants to be a good chatbot, a good assistant, because this discourse goes like this. You have to understand it's the assistant psychology. It sees itself having given the last answer like this in a pirate language. But it looks at that in horror, basically. How was I so unprofessional and so on? It completely unreasonable response and so on. So it tries to fix and give a more kind of neutral language answer. But how can we kind of change it a bit? We can thank it. I love your style. So now it knows that it actually was a good chatbot when it answers in pirate language. And when we give exactly the same question, it answers in pirate language, at least partially. Yeah. So you can see that it has multiple motivations at play and sometimes in conflict. And if you want these chatbots to work to perform a specific task, you have to keep those motivations aligned so that the chatbot isn't constantly unsure about what it has to do.